Hello everyone. In this video I'm going to show you how I tested the gaming system that my daughter built. Remember, she had that MUSETEX case and I had some questions about it at the time. So you'll see how that all worked out. Right in the beginning here, I do want to mention, if you find that this is helpful in any way or you get information out of it that you find useful, please do me a favor and subscribe to my channel. Here we go. Hi again everybody. I'm now going to do a general test of my daughter's new PC. I'm going to make sure that it can handle the heat generated by Prime 95 and then monitored by the program Hardware Info. So I'll let you watch along on the screen here. I have my capture card set up and we'll go ahead and see what I can do here with this. Hopefully it runs fine. So the first thing I need to do is run the utility software. I have them stored in a separate directory here on a desktop, and I'm going to run the Hardware Info 64. I like to rearrange these windows a little bit. I don't need to get an update right now. Get all of the sensors going. Right now it's running at an interesting temperature. Well within specs, 29 degrees centigrade. Like one core is maxed out at one point, a little bit higher, but not much. Right now 29, 30, 28. It's this whole area right in here. I'm circling with the mouse. All 6 cores. With that, let me go ahead and run Prime 95. Put some stress on this thing and see how it performs. Get this guy kicked off. Let me pick a nice point to start it at. Let me restart so I get the sensors running at the same time. Restart the sensors. I'm going to start 95. So the timing on the bottom of the screen here match. To get 15 minutes out of it, see how it goes. Right now you can see the temperatures are kicking in pretty high off the bat. Up to 67, 68, 75. Looks like core 1 is running a little bit hotter. 3 is right behind it. Up to 70, 77. It's a bit hotter than I thought it would be. See how it goes here. It's to 80. Say hit 81. It's a little bit slower in catching up. So the only fan that's in here right now that's PWM is the actual processor fan that we installed here. To see, high is 84. Typical point is usually about 5 to 6 minutes found with this program. Cores are maxed out here, the center top of the screen. 5 minutes. We're starting entering the critical 90 seconds. From this point forward, it's going to tell us a lot. If it makes it past about 6.5 minutes, I'm running at 5 minutes and 13 seconds here. If we make it past the 6.5 minutes, then we're pretty good. Still hotter than I'd like to see, on especially core 1, but well, it just hit 90. Just as we're hitting the critical part, 5 minutes and 30, 93. The CPU package is 91. We're not thermal throttling. Oh, we just thermal throttled on core 1. So right at about 5 minutes and 40 seconds, we started thermal throttling on core 1. That is not good, but just running simple processors. I have not seen any of the PCs I've built so far hit that kind of temperature. But then again, this is the first one I have that actually has a very limited, only one PWM fan running. So there's no way for these other 4 fans, the 3 pretty ones in the front here and that 1 pretty one in the back, for them to know what's going on. They're running at one fixed speed. They seem to be pretty silent, so chances are that speed isn't too fast. I could put a RPM meter on it and see what they're running at, but my guess is that we're probably below 1,000 RPMs for sure. I don't like to see red numbers on there. Sorry, I just really don't like to see it. Let's go a little bit low. It looks like we might be past the critical point right now. I know the cooler was on right. The thermal paste was on correctly. Those were things I validated as my daughter put those on, so I was being very careful about that. I don't like it with these fans running the same speed no matter what. I think on the second test I may go ahead and run it with the front glass off and see if that makes a difference. It does worry me that I don't feel much air being sucked in here at all, and only a moderate, and it's warm air coming out the back for sure. You can feel that. Let me go ahead and do a capture on this because I may want to graph this later. I'll save it to the desktop. Initial. I'm going to give it a 01 on it. And I want that to be a JPEG. I'll save that. It's running nowhere near as hot right now. Let me close it at this. This is probably good enough. Stop the test. I'll save this here as I let it cool off a little bit. I can look at the temperatures, the sensors, find out where it's settling out at. Before it was approximately 29 degrees centigrade with all the cores running normal. Right now we're at a few centigrade higher than that. Let me take the front glass off. And try this again. Let me go ahead and try it again. So we'll run the sensors first. Make sure that the temperature is lined up. They are at 29 degrees plus or minus a degree. Time 95. I'm going to start it. It's 26 seconds behind, but that's okay. Let's see what we get now. And we're just about hitting 5.5 minutes, so we're starting to enter critical. It jumped up to 88. And we throttled on core 1. So we actually did thermal throttling on core 1. We hit 95 degrees, 94, 95 degrees, 96, 98. So it's absolutely the same temperatures, really. A little bit further away from TJ Maxx, but no, not really. Really didn't change anything. So opening up the front did not change it. That's disappointing. Probably wouldn't have wanted to run that way, but at least it would have been an option if it had stayed cool. And coming up on the 6.5, that's usually the junction point. Usually if we hit the high point before we hit 6.5, still no good. I can't have even one core throttling on you. Something else with this thing. I'm going to go into the assumption that these fans are just not generating enough cool air in here for this particular CPU under load. So with that assumption, I think I'm going to go with my default, because I'm confident that the thermal pace is correct. I can't guarantee my life, but I didn't notice any sort of obvious waves in any of the metal, either on the top of the CPU case, the hood, or the cooler master plate, cold plate. So with that in mind, I think I'm going to try to add a couple of fans. Might just try one, but I think what's happening is we have a hot spot here. This is warmer than I would like to see. Very rarely do you actually feel the heat on the case. If the heat got up this high, I'm thinking it's just not getting the hot air out quick enough. So definitely I want a fan here blowing out. But if I'm going to do a fan blowing out here, then I may starve the processor fan intake. So what I'll do is I'll put another one blowing in somewhere, and the only other place it can go right now that won't interfere with the pretty colored RGB ones is at the top blowing in. That would then match what I've done to my main system. I have done the same thing on that. It's part of my cooling strategy. Right before the cooler I have a fan blowing in, and right after the cooler I have a fan blowing out. So it's probably something to at least try as we approach the 10-minute mark. After about 10 minutes I'm going to do another screen capture, and then we will proceed probably with the upgrading of the fans. They're PWM, and there are 2 free PWM connectors right now on that motherboard. There happens to be one a little bit south of the memory, And so that fan blowing in will be dealing with that automatic sensor. And then there's definitely one up on the other side, about the same height, right below the processor on the other side of it. So that would be handled by the one pulling the air out. So I think that's a pretty good strategy to try that. But let me go ahead and do a screen capture of this. Screen capture this guy. Save as, I'm going to save this as O2, but I'm going to call it the PC no front glass, just so I know which one it is. No front glass. Save that. Okay, I've got these two fans that I just recently purchased from Corsair. They're the ML20. They're fully PWM, and they have a maximum RPM of 2400. But these are very nice. These are the same fans that I have in my main computer down here that I've shown before. I do already have these rubber grommets I want to put in here to try to dampen the sound of the fans, however, a little bit, just a little. So if I pull these off, get them onto each of the corners of the fans, so they actually come out looking like this, I can put them in each of the corners and dampen the vibration just a little bit. There is no buffering area there on this particular case, so I'm creating my own with these rubber grommets. Okay, so I got one that'll blowing in and one that'll be blowing out. So this is the fan that will be blowing out. So that'll be the first one that goes in. This one in here, screw started. Now this one's gonna go opposite. I want this one to blow in. I'll make it so that I can get to this wire, because right in here is the actual connector for that one. So as I come in here, this connector here is the connector for that particular one. Two extra fans, one blowing in and one blowing out. And let me cable tie these so I don't wind up with them jamming up in the fan. And you can see here, as I bring it around, fairly neat package, as neat as it's going to be anyway. It's actually connected way down in there. And then we're done. We can go back to heat test. Okay, got it back up again. I put the glass panels on, and I decided to go into the BIOS first to make sure of a couple of things. I do see the fans running, but I want to make sure that I can see their RPMs and other information about them. So we got 3 fans running now. In addition to the CPU fan, we got a chassis fan 1 and a chassis fan 2. As I recall, the chassis fan 2 is the one that's actually blowing in. Double check that later, but that's the one that's blowing in. And it's feeding the overall CPU cooler fan. And then on the other side, chassis fan 1 is sucking it back out. What I'm going to do first is do a fan tuning. This QFan control, it's a nice feature. I love it in ASUS. I'm going to go into the QFan control here, and I'm going to put it on full speed option. Now it'll adjust automatically, but I'll start off with full speed. So you'll see as I look at this, CPU fan is a PWM. It's running at full speed right now. The chassis fan 1 is also PWM. It's not if you see DC, that means it's a non-PWM one, and it has a ramp up to it. And then chassis fan 2, similar. It starts off at a higher RPM, that's all, by the current tuning. So I'm going to do an optimize all, and there is no AIO pump in here, so that one's disconnected. So I'm going to go here and I'm going to do an optimize all. The thing will go through a set of cycles. It'll ramp down, ramp up, and so forth. It says here, when I click OK, it'll take 2 to 5 minutes to not shut down or reset during the tuning process. Okay, understood. Here we go. Like, you can really hear them pumping out at this point. They're really going strong. Some blowing in, that one blowing out. Let me put the other filter on top here. So we have that in it. And it's coming up with a ramping plan for those fans to keep the system cool under certain conditions. I like it. It works very well for my existing server, desktop computer, excuse me, and hopefully it'll work well for this one. That actually stopped the fans at this point. The PWM fans have actually stopped. completely. And it's checking the temperatures, I'm sure, at this point to see which ones are heating up. Now they kick back on again. I can actually see it happening inside of the case. It stopped all the PWM fans stopped. These other ones, the 4 RGB ones, just kept on cranking. So it came up with ramp plans for the CPU fan. It'll go from 144 down to 17. Chassis fan 1 will go from 15 to 27. And chassis fan 2 will go 31 through 36. So it's going to have minimal changes. Okay, we're good. Let's get out of this. Escape. Chassis fan, the CPU fan is actually running at 2000 RPM right now. So it itself is not going to pick up that much speed once we go. It's not loud, so I'll leave it like that for now. We'll see how it goes. Say save and exit. It's going to warn me, I'm sure, how it changed all the fan speeds from their normal to something different. Well, everyone, I'm going to cut it at this point in terms of the testing. And even though I actually completed 5 more series of tests, because I did each one many times, the results were not as good as I had hoped, and I'm not going to bore everybody with that. Now, the steps I performed are listed here. I did add the 2 additional PWM fans at the top, and then I retested. I removed the tempered glass on the side, and I retested. And then I did 2 things, removed the CPU cooler and cleaned and applied the new thermal paste, but I also added a second fan to the CPU cooler in a push-pull configuration, and I tested then. Finally, I reversed step 2 by putting the CPU cooler with just 1 fan, and then I put the PWM fan at the rear exhaust, replacing one of the case-provided RGB fans. To the most part, however, none of these tests really made any significant difference in terms of making the system run any cooler. In fact, as you'll see in the next chart, some of them actually made it worse. This chart actually shows the result on the core throttling with each of the various tests that I did. I also counted the number of cores that neared throttling. And this chart actually shows the effects on actual core temperature, which I include both the max CPU temperature and the CPU package temperature based upon the results of each of the scenarios that I tested. Now, just for completeness, in this next video clip, I'm going to show you how I have validated the actual speed of the fans that came with the case, those RGB fans. Okay, what I got now is my tachometer. I am going to check the speed of the fan. In particular, I'm interested in the ones that are just controlled through the RGB mechanism for this particular case. But I'm also going to compare it to the other ones. What you have with the tachometer is these little reflective tapes that you cut off a little piece of it, a little square, and you put it on whatever it is you want to measure the RPMs for. That's revolutions per minute. So what I've already done is I've already gone ahead and placed the actual tape on the fans. So this is the actual reflector on the case fan that we have no control over its speed. And this is the reflector on the cooler for the CPU, which we do have control over, but more importantly, I have the ability to monitor through the BIOS what the speed is of that fan. So then we'll find out. Let me go ahead and bring this up. I'm going to go right into the BIOS. It's hitting the delete key on the keyboard. There we go. So right now we can actually see the speed of the fans as recognized by the motherboard. So for purposes of this demonstration, we can actually see that the fan speed is registered right on the BIOS screen. So right now the CPU fan is running at 779, 805. It fluctuates. So approximately 800 RPMs is what it's running at. The 2 Chassis fan 1 and Chassis fan 2 are the fans that I just recently added. So I'm not going to check those. I'm just going to use this one to synchronize the tachometer with. The way it works with the tachometer is you have a button here that is test. I'm not going to store anything in it. It does have a storage capability as well. This is relatively cheap. It'll be down in the notes to this video. It costs like 20 bucks from Amazon. So when I hold down the test button, it will show me what the RPMs are as long as I have the reflective tape in the laser sensor that this thing will produce. So for example, let me go ahead and try it here, and I'll go on the fan for the CPU. I don't know if we'll see this on the camera or not, but when I turn the laser on, I know where I put it, and if I see something that looks like a square and a little bit of reflection to it, there's a little bit of reflection to it. I don't know if you can see that in the camera or not. And what is the tachometer saying? it is saying that we have approximately 850 RPMs that are being seen by this particular tachometer on that fan. Does that match the screen? Yes, it does. The screen says 840 approximately, so close enough. So now with that, let me check the fan on the case. Same thing, I gotta find the little square. You can actually see the little square where the reflective tape, you see the outline of it carefully in there in red. And this thing is saying what? 1370 approximately, 66 RPM. So those fans are not going as slow as I thought, but still they're not changing speed depending on the load on the CPU. Well, I found out what the root cause of this problem was, although it's not something I could do much about without severely impacting the performance of this system. It turns out that my default function of turning on the XMP, or extreme memory profile, is what's leading to the heat generated by the processor to go up so much. That allows the motherboard to clock the memory, the DRAM memory, up to its maximum speed supported by the motherboard and or the memory, whichever one is lower. I also tried something in between by forcing the motherboard to clock it at an in-between frequency, in this case 2400 megahertz, but that didn't make any difference either, as you'll see in the following charts. The top chart shows actually what happens in terms of throttling. The bottom one shows the temperatures between whether or not I have XMP disabled or not. With it disabled, we're within normal temperatures, and we have no core throttling. However, even trying it out at the 2400 megahertz, it still had the same problem. At this point, I think it's obvious that the only thing we can do to solve this is to put in probably an all-in-one cooler. I've already talked to my daughter, and considering the price drops on those all-in-one coolers, especially a 240 millimeter, I'm going to go ahead and get one of those for her, and I'm going to go over to her apartment and install it. And I'll make a video about that and show you what the final results are. So please look out for that video in the near future. Well, everyone, that completes the testing and some of the remediation, actually, that I did to try to resolve issues with the cooling in this case. So hopefully you got something useful out of this video and you'd be inclined to subscribe to my channel. It's the only way I can grow and provide these videos in the future. And I have many other videos that I'd like to do. In any case, if you could just click on the little head here and follow the instructions, I would really appreciate it. Thank you, and until the next time, take care.